Right, so welcome to this video on working backwards on ellipses. I was going through with my class group and basically what kind of questions it could be asked in section 8, the kind of skills students are missing for drawing ellipses. Right, so essentially what students have difficulty on is how to draw an ellipse when you're working backwards, right? So here are the scenarios they have difficulty on, and they also have difficulty with tangents. How to draw an ellipse when given a point on the curve, the ellipse, and given the major diameter. How to draw an ellipse when given a point on the curve and the minor diameter. How to draw the ellipse given the focal points and the point on the ellipse, so the two focal points F1, F2, and then a point on the ellipse. Okay, that's the third scenario. And then they sometimes struggle with drawing tangents, so how to draw a tangent from a point on the curve. Okay, on the curve, and then how to draw a tangent from a point to an ellipse from a point outside the curve. So from outside the curve. Okay, there. So we'll begin with this one. So I'm given my point P. I have my major diameter, so in my question my major diameter is going to be 52, or sorry, that's my major radius, so 104 is my major diameter 2. Now this is working backwards from the concentric circles. I'll zoom in a moment, or I'll zoom in there. So this is working backwards from the concentric circles. So in the concentric circles method, I've drawn an ellipse. We have the major and we have the minor in the concentric circles method, and we know we divide it up into 60-30, so just do a quarter, or a quadrant rather. We divide it up into 60-30, and where it hits the big circle, the major circle, we go parallel to the minor axis. So, and the divisions are line number 1, then this is line number 2, and where the division line hits the minor circle, we go parallel to the major, that's line number 3, and they intersect at a point on the ellipse. Okay, now this is working backwards. So the first line was the sloped line, the second line was this one, number 2 here, and then number 3. So over here we're going to go and draw in our major circle, and then from P we're going to go parallel to the minor axis until we hit the major circle. So this is line number 1. Now the slope line will be drawn in next. So we join that back to the center point. Okay, so that's the division line. It doesn't have to be at 30 or 60 degrees. Okay, and then we're going to go backwards from here. From P we're going to go parallel to the major axis towards the middle. And there you have your point on your minor circle. Then you can draw in the circle, you can divide it up then into 60-30, and you're away then. So yeah, you're away. don't think there's much need for me to actually show you how to draw in the ellipse. So once I do the divisions, okay, which I have done there, I'm going to move on. So I'll pause the video and sketching the ellipse myself. So a reminder, when you're given the major and the point on the ellipse, okay, go parallel to the minor axis from point P till it hits the major circle, join it back to your center line, or your center point rather, and that is its division line for this respective point P. It doesn't have to be 60 degrees or 30 degrees. And then from P, go parallel to the minor axis towards the middle, and they intersect on the minor circle. Now, scenario 2. How to draw a point on how to draw an ellipse when given a point on the curve, okay, and the minor diameter. Okay, so I'm going to say my minor diameter will be 60. I'm going to say this is a point on the ellipse here. Right, so a reminder, this is based on working backwards from the concentric circles method. If you're given your major and your minor, you know yourself, you divide into 60/30. You get, oh Jesus, the light has gone and destroyed here. One sec there. There's nothing really I can do about that shadow. So you'd go parallel to the minor towards the major, where the division line hits the minor circle, parallel to the major, away from the middle. The key thing about these working backwards methods is that the division line can be any angle. Okay, any angle is the key thing about it. Right, so over here we have our minor circle. So we're drawing our minor circle, and I put the axis sloped to make it, what you call it, a little bit more difficult. So here's the minor circle. This is the major axis. That's the minor. So from point P, we're going to go parallel to the major axis until we hit the minor circle. So from point P, we're going parallel to the major axis until we hit the minor circle. So that's what we're doing there, that line going backwards. Now we're going to draw in our slope line, our division line. So from the center, we're going to go through this point of intersection, and somewhere along here lies the point on the major circle. So then from point P, we're going to go parallel to the minor circle away from the major axis, or sorry, parallel to the minor axis away from the major axis, and they intersect at a point on the major circle. And then you can draw this in. And then you can draw in your ellipse. So you can. So where the division lines hit the major circle parallel to the minor axis towards the middle, so towards the major axis. So where the division lines hit the major circle parallel to the minor axis towards the major axis. And then where the division lines hit the minor circle parallel to the major axis away from the minor axis. And I'll sketch those points in now. And then that's done. So we'll move on to a third scenario of working backwards with the ellipse. Okay. So here we have our focal points, F1 and F2. Now, so F1 to P and P to F2 is the length of the major diameter. So I'm going to join F1 to P and P to F2. Okay, now you can draw a construction line along the bottom of your question. So construction line along the bottom of your question. Take your compass, set it to F1 to P, and step it along that construction line. And then take P to F2 and step it along here. Alright, and this is the length of the major diameter. Now to get half of that, you can take your compass and you can bisect the line. You can bisect the line. So this is half the major. Now you can swing that from the center. If they didn't give you the minor axis here, well then bisect F1 and F2. Now you take your compass here, you can swing in your major circle. A lot of students seem to think that the major circle is the center to F2. That's what I see. Okay, maybe it's me that's teaching poorly. Okay, but a lot of students make the misconception that F1 to F2 is the major diameter. It's not. V1 to V2 is the major diameter. Now, from here, okay, we have two choices to get the minor circle. Okay, if you have the major diameter and you have the focals, you can take half the major and swing from the focals. So you could take half the major, swing from the focals, and they intersect on the minor circle there. So that's the minor circle. And then the alternative strategy, okay, might be a little bit inaccurate here, but the alternative strategy would be to apply what we learned up here in scenario number 1, where we're given a point on the ellipse and given the major diameter. So we could go parallel to the minor until it hit the major circle, join back to the center of the major circle, and then go parallel to the major axis back towards the division line, and they intersect at a point there. Right, I'll go ahead, draw that in. So divide it up into 60/30. So I'm just going to pause while I do this. So we have that done. Right, now the next thing I'm going to show is how to draw a tangent to an ellipse from a point on the curve. Okay, so I'll pick a point here, P, and this is the point of contact, right? So what I need to get is the focal points. Now, to find the focal points, take half the major and swing from the top of the minor. So half the major and swing from the top of the minor. Okay, now you've got your focal points. And the reason that works is F1 to the top of the minor plus the minor to F2 is equal to the major. So now F1 and F2. Right, the next thing I have to do is join F1 to the point of contact. So F1 to the point of contact and F2 to the point of contact. F2 to the point of contact. Now, I'm going to take my compass then and I'm going to bisect that angle. So set your compass to any radius. Set it to any radius. So swing an arc. Okay, I'm just swinging an arc there. It doesn't have to touch on the focal, so I might make it bigger just to make it easier to understand. So swing an arc there. And there. And now from those arcs you're going to swing again. The radius of the compass hasn't changed, right? And this is something called the normal. Right? That line there is called the normal. And the tangent always makes a right angle to that. So you can get your two set squares then, or you can use your t-square and your set square. Okay, you're going to line the numbered edge of your set square with your normal, and you're going to slide it down to the point of contact, and you can draw in your normal. So you can. Just an extension of knowledge to show you there, right? If you want to do from F2, you could extend that on and extend this line on too, and if you bisect this angle you get the the bisector is the tangent. So look, if I bisected that angle there, the bisector is the tangent. So there's just another piece of info for you. Now, down here, how to draw a tangent from a point outside the curve. So my P is over there, but I'm actually going to switch it over here. Now you see, generally this is what this one is the one students don't get. These two, right, the difference between these two is in the first one you have the point of contact. In the second one you don't. You have a start point on the tangent. Okay, you have a start point on the tangent. So for this one here, you need your focal points again. So take half your major, and swing from the top of your minor. Swing from the top of your minor. 1, F2. Now, put your compass on the start point of the tangent, where the tangent begins, and bring the nib to the nearest focal, and construct an arc. So construct an arc. Now, set your compass to the length of the ellipse, so the major diameter, or V1 to V2. So set your compass to the major diameter, or radius V1, V2. And from the furthest focal point, and what do I mean by furthest focal point? The furthest from the start point of the tangent, you're going to swing an arc. and where they intersect, all right, the first circle, you're going to join them to the furthest focal. So you can join them to the furthest focal, and where they intersect the ellipse now, you have a start point for a tangent. You could draw in two. You could draw in one there and one here. So look, now you have a tangent here, and you could do another one if you were asked to here as well. And that's that. So to prove the difference between these two, so here's the point of contact here. So I could show you how, I'm just going to do this in color, how if given the point of contact, the first method would work. Look, F1 to the point of contact. There might be a little bit of inaccuracy here. Bisect the angle. So there'd be your normal. And you could line it up there. And there'd be your tangent there against that edge there. Right, I was going to stop here, but I'm going to do one more for the crack with G. Just it's unlikely to come up at a higher level, but it can do it, right? And I'm going to do it just here, kind of in the center of this page here. So I'm just going to pause the video now and get it set up. So here's one for you: how to draw an ellipse when given a tangent, okay, and the major circle. Right, it's not as commonly asked on the state exams, okay, as the others, but it is possible. Now, when a tangent hits the major circle, from the points of intersection, if you go at 90 degrees to the tangent, you get the focal points, right? You get the focal points F1 and F2. Okay, and then if I want to get my minor circle, then I know I can take half the major, okay, and swing from the focals and then you have your minor circle, and you can do your 60-30 division. Okay, that I'll go through it this time. I'll do a quarter of it anyways. And then we know here's our 2 points on our ellipse. Here's the further one. Here's the further one. And if you're asked to find well, you wouldn't be asked, you have to find the point of contact between the tangent and the ellipse. Extend this line on. Take your compass. Put it there where the tangent intersects the major circle. Swing F1 up, because it's the same as the method down at the bottom right. Okay, and then from F2, okay, you can swing your line back. There's your point of contact, and then you can freehand sketch your curve in. Right. Cheers, thank you, bye bye.